Hi guys, welcome to another session of Null Delhi and OAS Delhi webinar. We are hosting it on a weekly basis, as you can see. For now and for today's webinar, we have with us Chandrapal, all the way from Bangalore. And just let me pop him up on the screen. Hi, Chandrapal.
Hello, Pratul.
Hi, how are you?
I'm doing good, man. Thanks for asking. How are you?
Yeah, I'm doing good. We are just stuck up here and we are just having these online webinars on a weekly basis.
Mm-hmm.
And we do just
Mm-hmm.
host up single webinars every week, and so as to give out the information, and because the information sharing should not stop even at such times.
True, true.
Yeah. So, guys, today we have a it's a very interesting session by him, and yes, the slides will be shared by him at the end. So please refrain from asking from this question, and yeah, the YouTube link, and you can view it on YouTube, and whatever questions you have, so Chandrapal will be taking up after his webinar. So I'll hand over the screen to you. You can start sharing your screen right now,
Uh,
Chandrapal.
sure. Yeah.
Okay, so Vaibhav also joined us right now.
Mm-hmm.
Hey,
Hi, Vaibhav.
hi everyone.
So Vaibhav
Hi.
is Vaibhav is a chapter leader for OVAS Delhi, and he will be our co-host in welcoming Chandrapal to our webinar. So, Vaibhav, we are just about to start off with the webinar. Yes, we can see your yellow earrings.
Cool.
Okay,
Hey,
so
hi Bacha.
I introduced Chandrapal, so I'll just let him.
Hey, Vaibhav.
Hi. Thanks
Sure.
for joining us.
First of all, thank you. I got to thank you, folks. Thank you, Pratul and Vaibhav, for this amazing opportunity to share knowledge on Nal Daily webinar. So, if you have this is actually Sunday and it's 4 p.m. If you have anything hot like coffee or tea, you could just grab a cup. I'm sitting here grabbing a cup of lemon tea, which is awesome. In this talk, I will walk you through some basics of DNS takeovers, like some basics of DNS, introduction to DNS takeovers, and different types of takeovers and their impact. And at the end, I will show you how to remove this misconfiguration altogether. So, officially, welcome to my webinar, Securing DNS Records from Takeover. If you have any doubts, as Pratul said, please hold it till the end of the session or leave it in the comment section so that I could answer that later. Let me introduce myself. I'm Chandrapal Bacha.
Um,
I'm a security engineer at Day, and my daily routine looks like do a lot of pen test, do automation on both offensive and defensive side, and read books whenever possible. I'm more into philosophy and stoicism, so I would read a lot of books on philosophy on the weekends, because that is philosophy is something that teaches you how to live and how to think. It is not just for people who are lazy. It's real good stuff. I also manage something called Hack with GitHub handle on Twitter, where I retweet and tweet all the GitHub tools on security, which I found pretty interesting. If you want to follow me, you can follow me on at the rate BN Chandrapal on Twitter. I am only on Twitter and pretty active there. Or if you want to check out my research work, you could always go to batcha.io website. Let us start with the basics. What is a DNS record? You could think of a DNS record as a mapping of a human friendly name like google.com or amazon.com to an IP address. And as you can see, there is a asterisk here. That is because not all DNS record types actually point to IP addresses. Some record types actually point to another records instead of direct IP addresses. All this we'll be looking into it a bit later. Like if you're from a developer background, you could think that as a key value pair, where the key is always a human friendly name like Amazon or Google.com, and the value is pointed to a resource. The resource can be IP address, or as I had mentioned earlier, it's another human friendly name. Now we all have this DNS records, and where do you put them? We put them in a DNS server, which is also called a name server, and it's just a simple database that it is not a database, it is like a database that hosts these DNS records. There are multiple types of DNS records. The most common you can see is a record, where the human friendly name or the domain name is pointed to an IP address. You also have canonical name records or CNAME records, where the domain or the human friendly name is pointing to another DNS record. This is done for most of the times for having an alias of another domain. AA record or AAA record, however you call it, it is a DNS record type which maps to IPv6 address. And there is a mail exchanger record, which is MX record, which maps to the mail server, which is responsible for accepting emails to that particular address. And NS record is the address of the server where all these DNS records resolve. So each domain should have at least one or two NS records. So this maps to the authoritative DNS server of a website. And if you look carefully, you can see a cool thing. A records only point to IPv4, and this record points to IPv6. However, NS records do not point to IPv4 or IPv6. Like CNAME records, it should only point to another domain name, and MX record should also point to other domain names, likewise NS record. And another catch in MX record is we use this particular number. I would use a pointer. We actually use this number to denote the priority of the mail server. If you want to know more about DNS and how DNS works, there was an amazing talk given by Omkar at Null Bangalore last month. You could check out his talk called a DNS Primer. Now, with some basic understanding of how a DNS, what is a DNS record and what are the different types of DNS records, let's jump directly into DNS record takeovers. You might have heard this as different names like subdomain takeover or domain takeover, or you could have heard about dangling DNS. Actually, dangling DNS is the main root cause for a subdomain takeover. And dangling DNS records are simple DNS records, they are just normal. But the catch is they are out of date records, and it may have served its purpose in the past, but it's not required anymore at this point. In simple terms, you could call a dangling DNS record is a valid DNS record pointing to an invalid resource. When I mean invalid resource is a resource IP address or another DNS record which is not trusted or owned by us anymore. So subdomain takeover or DNS record takeover is just the exploitation of these dangling DNS records. Uh, for takeovers, it is not a single record or a single type of takeover. Out of all the DNS records which I had discussed and which are in use, there are four known to be vulnerable. They are the CNAME records, the A record, MX record, and NS record. Cname Takeover. In this case, what we do is we try to gain control over the resource that the CNAME is pointing to. Now, since Badsha.io website is having a CNAME record to this, to take over this particular website or subdomain, we try to register or take over this particular endpoint, not endpoint, this particular uh, DNS record. And this is the most common subdomain takeover method. When you just go to HackerOne and search like subdomain takeover, when you go to Google and say that, okay, get me all the reports on HackerOne, which has the term subdomain takeover, you get lots and lots of reports. And what you find most common is it is a CNAME record takeover. This is most widely exploited attack vector because of multiple reasons. The first one is easy to judge if a CNAME record is actually vulnerable because of some identifiers like error messages. So, app not found, or this website does not exist, register to own this website, or something. And most of the bug bounty programs consider this kind of subdomain takeover as medium or to high severity bug. So it is easy money if you find one. Detection of these dangling DNS records, which point to a CNAME record, a CNAME record can actually be completely automated. So it is easy to get money if you find it, and it is not just a mistake on the company side or the person who owns the domain DNS records. Lots of SaaS vendors are also part of this blame, because if most of the SaaS vendors or lots of SaaS vendors do not have proper verification to verify if a person or an account owns a particular domain, and abusing this, attackers get access to the CNAME record. One noteworthy repo is Ed Overflow's Can I Take Over XYZ. This repository has multiple error messages which will say that if a particular CNAME record is vulnerable or not. And the common reason for this uh, vulnerability in the first place is SaaS providers allow to register or reuse the same resource name. If the SaaS providers do, then if you just get out of the platform, someone could go into the platform, register on the platform, and reuse the same resource which was allotted to you. In that case, if you had any kind of DNS record pointing to that resource, now your DNS record is pointing to a resource which is owned by someone else. And another common reason is expired domain. If a CNAME record is pointing to an expired domain name, domain names Next is a record takeover. This is not documented in multiple places, but it is being exploited in the wild. In this attack, we try to gain access to the IP address pointed by the A record. In this case, this IP address. This is more common than dangling DNS, but less exploited. There are a few reasons for this. You could ask, okay, why is this what more common than dangling DNS record, but not exploited like dangling DNS, like CNAME dangling DNS? Because there is no easy way to distinguish if a particular IP address is available for takeover or is just behind a firewall, or even it was already assigned to someone or some cloud user. Also, less probability of finding it inside your bug bounty scope. Sometimes you can get or you can take over a DNS record, but that DNS record might not be inside your bug bounty scope. And a lot of this takeover depends on the cloud providers. If the cloud provider just assigns you a random IP address from their entire pool, then you have a higher probability to take over any vulnerable A record takeover, a vulnerable A record. But if a cloud provider just gives you an IP from a smaller set, then you have lesser chance of exploiting. You, uh, you could ask, if this is very less exploited, then why exploit it in the first place? You don't get bounty of out of it. But this attack can actually be exploited for malicious file or malware distribution or malvertising. Just imagine a subdomain of Alexa top 500 websites is vulnerable for a takeover. Now you don't get bounty out of it, but a malware distributor can just go ahead and take over it and distribute it. Since most of the online virus companies trust the Alexa top 500 domains, maybe your malware just escapes that for some time. Also, what makes this exploitation a bit difficult is, unlike CNAME records, one subdomain can have multiple A records. So if you just own one A record, or if you take over one IP address pointed by A record, which also points to another three records, then the total exploitation is just 25% of the users who try to connect to the website. Next is the MX takeovers. In this, we try to gain access to the resource that the MX record is pointing to, which is for Google this and this. And as I had mentioned in the beginning, MX Records has something called priority. So whenever a email server tries to connect to emails of say google.com, it first fetches all the MX records, and then it tries to connect or deliver the email based on the priority. In first try, it tries to connect to this and deliver the email. If this is not possible, then it goes ahead to the next one. This MX takeover has comparatively low impact than other takeovers. This is because MX record, unlike Cname or a takeover, does not allow you to host your own custom HTML or phishing pages. It just allows you to receive emails. Also, usually there are more than one MX record for domains. If priority also matters, because if because say for example, if you take over MX record whose priority is very low, then if an email is to reach that particular target domain, it checks all the records which has higher priority than that. So a email reaching your server which was actually taken over is pretty less. Not every subdomain has a MX record. Mostly it is just configured for the main domain, and subdomains don't really have it. The impact for this for having a successful exploitation is just email fraud, because this particular email or this particular domain could be used in the reply to address when when sending phishing emails. And if there is any email which is sent to this particular IP which was taken over, then we could have intellectual property disclosure. Next, we have NS takeovers, and this is to take over or gain access to the NS records of a domain. This is least probable to all methods but have higher impact. Let's look at why it is less probable compared to other methods. Because every domain, when you register, it is you actually configure more than one NS record for the domain. You seldom use it for subdomains. You don't really have to configure any NS record for a subdomain unless you are actually having a subdomain of a subdomain, which has its own name server. And if a name server is not properly set up, then the subdomain resolution itself will not work. So if the domain is being used, they will find it out. Typos do not have a place in this, because if it does not work, then system admin folks or the ops team will correct it. High impact as NS takeover makes you the authoritative DNS server. Say, for example, if you're just one among two name servers, then 50% of the DNS queries asking what is the IP address of subdomain.target.com to your IP address. Then you can host your own DNS records. You can say, you can point that particular subdomain to a malicious IP. You can do anything with it. But as I had mentioned, it depends on the number of configured NS records. The impact of a DNS record takeover. Uh, let's talk about A and Cname record takeover because they almost have the same impact. You could, after taking over a record or Cname, you could have phishing on it or ask for login credentials. You can have malicious files or malware distribution on the domains because you own the entire content. You own the IP which the DNS record is pointing to. You can register to services or third-party services where verification is just a text or HTML file upload. For example, SSL. SSL uses Acme V1, which is Automated Certificate Management Environment, which allows you to tell others that you own a domain if you can host a text file or HTML file. So if you are able to take over a record or a CNAME record and have the capability to host HTML or text files on it, then you can issue yourself a SSL certificate. Also, you can chain this vulnerability to take over user accounts. Say, for example, you can steal domain-wide cookies. You can actually take over user accounts in certain cases and other sensitive information. Looking at MX record takeover, It is mostly used for receiving emails, and if it receives email, it might lead to intellectual property disclosure, or it also has email fraud. It could be used for email fraud. NS record takeover is less probable but has complete control on subdomains DNS. Excuse me. Till now, we were talking on multiple ways to take over a DNS record. Now let's look at how to protect from these takeovers. You could be a person who thinks, okay, let me write down a tool or a script which automatically removes this from my company. But that does not work in reality. You require people and process to completely remove this bug class. Why people and process? Because if there is no process which says, okay, which tells the employees where to register and manage DNS records, then people are going to do it everywhere wherever they find it useful. This is most common scenario in startups. So first thing is have a centralized place for all your domain registrations and DNS record management. By doing this, you will make sure that there is no other subdomain in some other place which the company or the security team does not know. You also will know when was a DNS record created, who created that, and if you ask the person, you might also know why it was created in the first place. That is with the people and process. Then comes the technology. Technology wise, you can write down an audit script, and the logic is pretty simple. First, get the list of all the public IPs that your company owns from the cloud provider. Then get a list of all the custom domains or subdomains created by the cloud provider or other SaaS providers. Example, CloudFront or Elastic Load Balancer. Get now you try to get a list of all the DNS records which might be vulnerable or which could be exposed to this resource with public IPs and custom subdomain that you own and note it down. If any of these noted DNS records are not actually whitelisted, then it means this is pointing to a third party resource we do not even know. If it is whitelisted, we know that it is trusted by our company. So create a report on it, and also have a periodic check of all the whitelisted DNS records, because it should not be the fact that you whitelist certain domains and then you find out that these whitelisted domains had a subdomain takeover bug. So you could actually have a periodic check, like taking screenshots of those whitelisted domains or so, or you can just pipe it to automatic subdomain takeover discovery tools like Subover or Aquaton. So high level algorithm looks like this. You get a list of all the IP addresses, then you get all the resources, that is the subdomains custom subdomains for your services, all other services. Then you get a list of all the DNS records which you have hosted. Then you get the whitelisted DNS records which you trust, even though it belongs to someone else. Now, for each record in the DNS record, in the DNS records list, you go ahead and check each resource. When I say resource, if that particular record is pointing to multiple IP addresses, or if that particular resource is pointing to a domain or a subdomain, then check if that resource with all the IPs and all resources. If the resource is not present in all IPs or all the resources and it's not even whitelisted, then you can go ahead and report saying that, okay, this particular record and this resource, which is IP or a domain name, is not whitelisted and is pointing to somewhere else. Then you can connect with the person who created it to understand why it was created in the first place, and then if it is okay, you can whitelist it or delete it. Let's look at an example of how to protect from takeovers of an imaginary company. The first thing it does is it mandates all the employees to use AWS Route 53, which the company owns. Now it has also enabled CloudTrail logs on it, so that if any person creates Route 53 record, it gets logged into the logs. So if there is any future event or future incident or investigation, you can just look at the logs and go ahead and ask the person why was it created for in the first place. Then the security team gets a list of all the AWS services that they use, which creates custom subdomains for them, like AWS CloudFront, AWS ELB, Elastic Load Balancer, S3 buckets. Then security team writes an audit script which runs every day to fetch all the non-whitelisted DNS records pointing to third party. If this third party domains or the DNS records which are pointing to third party are okay and trusted, it could be whitelisted for the next run. If not, ask the developer or the ops team to delete it. By doing this, security team is being vigilant instead of being a blocker. That is what security team should understand in general, not being a blocker, and help the developers do their experiments. And if there is any case that it is going to have a certain risk or a vulnerability in future, just delete it. Now let's look at the demo. I have created a small POC of this Python code. I say that in the main function, I go and first step is get domains. This function gets all the DNS records from Route 53, then get all the resources that I own, IPs and CNames. So first is I go to CloudFront resources and get the resource, S3 buckets, ELBs, and AWS IPs from mostly EC2 instances. Then I combine everything. So all services, then I combine everything, and then all IPs is all the IPs assigned to my EC2 instances. Then if I have any whitelisted IPs, I also whitelisted DNS records, then I also consider them. In this program, I have made it to put that in CSV files. Then I check if for each record and for each resource, if they're not present in the all IPs and all services list and are not even whitelisted, then report it. It might look something like this. I have set up I have set up multiple AWS resources and have vulnerable DNS records on AWS Route 53. Let me show you how this script works. For this experiment, I have created a EC2 instance with this particular public IP address, starts with 100 and ends with 27. I have set up a CloudFront distribution. Then I have DNS records, a bunch of A records, a few CNAME records, MX records, and NS records. When you look at the first three records, they all point to the same IP address of my EC2 box. But when you look at old EC2 and VPN subdomains, it is pointing to IPs that I don't own. Next, there are a few CNAME records. I have pointed to GitHub, I have pointed to CloudFront. This CloudFront address is different from what I have hosted. So this CloudFront is an address that I don't own. I have MX record where I have made a typo called, instead of sendgrid, I just put send GRD. Then I have also hosted my own name server, which is NS1 and NS2. I have also made again another typo here. Instead of Bacha, I put BTASHAH. Now let me run this Python code. I have already configured my AWS credentials on this my local development box, and I'm looking at US East 1 region. When I run this file, it takes a small time because it's actually querying AWS for all the resources it has that I have spinned up. Then you get a list of violations which were not whitelisted at all. Now I could connect with the devs and ask if they need to be whitelisted. If yes, I go and create a CSV file. and add whichever domain that needs to be whitelisted. In this case, I add VPN subdomain, which is a record, then for Cname and MX and NS records as well. The process is same. In this demo, I'm just copying and pasting it as whitelisted, but in real world, I would go ahead and ask the teams if they really need this and why they would need this. And finally, I whitelist NS records of AWS, NS records pointing to AWS. I save all these whitelist files and run the tool again for the next iteration. In case there is a new domain created, or if the existing domain DNS record is changed, you get it here. Now you can see that I have a few typos here, MX, SendGrid, and name server. And there is untrusted CNAME takeover. I have global whitelist pointing to a domain of my partner. Do not actually trigger it or do not report it. You could have such whitelist placed in the code. This is just a POC of how it would work. Now, how you could ask a question, how do you protect this in a complex environment? Because what I showed in the demo was a single region, a single AWS region, but in reality, it could have multiple regions within the same cloud provider like AWS, or using a mix of cloud providers for their benefits. So the method remains the same, whereas the code, you just modify it to fetch all the IPs and all the subdomains from all these cloud platforms. And I guess I have finished it early. So you can look at my blog. Uh, I have already written about this and published yesterday. And you can look at the POC code, which is on GitLab. Thank you. Any questions?
Yeah. Thank you, Chandrapal, for the session. We will be taking up questions. We have one question. I'll pop it on the screen. Yeah. Chandrapal, can you see this
I will,
question?
yes, I can. What authoritative name server means in simple terms. Okay. Authoritative name server or a DNS server is the server responsible for resolving all your DNS queries. If I have a name server for google.com, now if I ask, okay, what is the IP which is pointed by sensitive domain.google.com, then DNS client connects to so many servers in the way to get the IP of the name server which hosts all the DNS records. That is the authoritative name server. So now our DNS client connects with that particular particular DNS record. No, that particular subdomain in the DNS record to resolve what is the IP. So in that particular case, you call whatever is mentioned in the name server as the authoritative DNS server. When it comes to non-authoritative server, the first few servers that you connect with, say if you want to resolve some domain.google.com, you ask a local client or a resolver. That resolver talks to root servers and then root server gives the address of the TLD server. TLD server is like .com, which is responsible for .com or .net domains. This particular domain then tells you where to look for google.com. So all this resolver that the resolver is talking to becomes a non-authoritative DNS server.
Okay. So I guess Piyush got his answer. You described him well. Thank you, Piyush, for the question. Um, if we have any other question, then we can take it up right now. So I guess that's it. Thank you, Chandrapal, for this informative webinar. I hope many people's query will have been resolved by this. And guys, if you have any other question, then you can ask him on Twitter, or you can just post it. You can post it on our comment section. So we will definitely try to have it resolved ASAP. So thank you, Chandrapal, for the session. Vaibhav, it
Thank
was a
you.
interesting
Thank you,
session.
Chandrapal.
Thanks.
Yes, it was an interesting
Thank you,
session,
Weber.
and we see a lot of these kind of issues, specs, especially after I think AWS S3 domain takeover issues. These kind of vulnerabilities have kind of popularized. So this was pretty informative, Chandrapal.
And he has
Hmm.
also written a
Thanks.
blog about it. Like yesterday, he had posted it on Twitter. So yeah,
Wow.
that's a good thing as well. So we will be posting, and we will be giving out the link for the blog as well. So yeah, that's it. Thank you, Chandrapal.
Thank you, Chandrapal. Thanks a lot, everyone.
So thank you all. So this was it for this week's webinar. We will be coming up back with a new webinar, I guess probably next week. Till then, stay safe, and yeah, happy Sunday. Bye bye.
Thank you, guys. Bye bye.